The National Electrical Code, or NEC, has specific requirements for the use of flexible cords, and these apply to both alternating current, or AC, and direct current, or DC, circuits. Section 400.7 covers the general use of flexible cords. Flexible cords are permitted for things like pendants, portable lamps, and appliances. They are also allowed for other uses as permitted in the NEC, but the cords must be of a type listed for the intended use and location. Section 400.8 addresses specific uses of flexible cords. For outdoor use, flexible cords must be listed for the purpose and marked with an S, cent, or so designation. Crucially, flexible cords are generally not permitted to pass through walls, ceilings, or floors. In the specific case of using an ISO cord for a powered awning with a 12 volts DC motor, several factors come into play. Since the ISO cord is listed for outdoor use, it meets that particular NEC requirement. However, the NEC explicitly prohibits flexible cords from passing through walls. Therefore, running the ISO cord through the exterior wall of a home to connect to a power converter inside is not permissible under the code. Several alternative solutions can achieve compliance with the NEC. Firstly, the ISO cord could be run along the exterior of the home and terminated at an outdoor rated outlet. The power converter could then be plugged into this outlet. Secondly, a junction box could be installed in the exterior of the home. The ISO cord would connect to this junction box, and then a conduit containing appropriately rated wiring could be run through the wall to connect to the power converter inside. Thirdly, a different type of cable that is permitted for through-wall insulation could be used, such as Type M cable, commonly known as Romex, which is suitable for household wiring applications. To summarize, the NEC prohibits flexible cords from passing through walls, ceilings, or floors, regardless of whether the circuit is AC or DC. Therefore, running an ISO cord through an exterior wall to connect a powered awning to a power converter inside is not allowed. It is essential to consider alternative wiring solutions that adhere to the NEC guidelines to ensure a safe and code-compliant installation. When selecting an appropriate wiring method, several factors need consideration, including the environmental conditions, voltage drop, and ampacity requirements for the circuit. In addition to the previously mentioned solutions, several other options may be suitable depending on the specific application and local code requirements. One option is to use a liquid-tight flexible metal conduit, or LFMC, which is a flexible conduit that is designed to be watertight. This type of conduit can be used to protect the wiring from the elements and can also be used to run wiring through walls and ceilings. Another option is to use an underground feeder, or UF cable. UF cable is a type of cable that is designed to be buried directly in the ground. This type of cable can be used to run power to an outbuilding or other structure that is located away from the main building. When installing any type of electrical wiring, it is essential to follow all applicable codes and regulations. It is also important to use the proper tools and equipment and to take the necessary safety precautions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Here's a more detailed look at some of the alternative solutions mentioned earlier. Firstly, running the ISO cord to an outlet. This involves installing a weatherproof outlet on the exterior of the house near where the awning is mounted. The ISO cord from the awning's motor would then plug into this outlet. Inside the house, a standard power converter could be plugged into a regular wall outlet. This setup is simple and avoids running any flexible cord through the wall, fully complying with the NEC. However, it does require an outdoor rated outlet and enclosure, which adds to the cost. Also, the power converter remains plugged into an indoor outlet, potentially consuming power even when the awning is not in use. Secondly, using a junction box and conduit. In this scenario, a weatherproof junction box is mounted on the exterior wall where the ISO cord from the awning terminates. Inside the junction box, the ISO cord is connected to individual wires that are rated for use in conduit. These wires are then run through a conduit, such as electrical metallic tubing, or AIMT, or rigid polyvinyl chloride, or PVC, through the wall and into the house. Inside the house, the conduit terminates at the location of the power converter, and the wires are connected to the converter's input terminals. This method provides a more permanent and professional-looking installation. It also protects the wiring from physical damage and the elements. However, it requires more effort and skill to install, as it involves cutting and bending conduit, pulling wires, and making secure connections. Thirdly, using Type NM cable. Type NM cable, or non-metallic sheath cable, also known as Romex, is a common type of electrical wiring used in residential buildings. It consists of 2 or more insulated conductors wrapped in a plastic jacket. Type NM cable is suitable for dry locations inside walls and ceilings. To use Type NM cable for the awning installation, the SO cord from the awning would need to be terminated in a weatherproof junction box on the exterior wall, similar to the conduit method. Inside the junction box, the SO cord would be connected to the conductors of the Type NM cable. The Type NM cable would then be run through the wall and connected to the power converter inside the house. This method is relatively easy to install and provides a neat and concealed wiring solution. However, it is essential to ensure that the Type NM cable is properly protected from physical damage and moisture, especially where it enters the junction box and the wall. Additionally, it is crucial to select the correct size of Type NM cable based on the ampacity requirements of the circuit. Apart from the above 3 options, it is important to also consider the wire gauge, voltage drop, and overcurrent protection devices such as fuses or circuit breakers. The appropriate wire gauge for the 12 volts DC circuit must be selected based on the length of the wire run and the ampacity required by the awning motor. A longer wire run will result in a greater voltage drop, which can affect the performance of the motor. To minimize voltage drop, a larger wire gauge may be necessary. Voltage drop calculations should be performed to ensure that the voltage at the motor terminals is within acceptable limits. Overcurrent protection devices should be installed in the circuit to protect the wiring and equipment from damage due to overloads or short circuits. The size of the overcurrent protection device should be selected based on the ampacity of the wire and the rating of the equipment. It is important to consult the NEC and other applicable codes and standards to ensure that the wiring installation is safe and compliant. Furthermore, one should consider labeling. Proper labeling of electrical panels, circuits, and equipment is essential for safety and maintenance purposes. All electrical panels should be clearly labeled to indicate the circuits they serve. Each circuit breaker or fuse should be labeled with the corresponding load it protects. Equipment such as power converters and junction boxes should be labeled with their voltage and current ratings. Proper labeling helps to prevent confusion and ensures that the correct procedures are followed during maintenance and repairs. In addition to the NEC, local building codes and regulations may also apply to the awning installation. It is important to check with the local authorities to determine if any permits or inspections are required. Following all applicable codes and regulations helps to ensure that the installation is safe and compliant and avoids potential fines or penalties. When working with electricity, safety should always be the top priority. Before starting any electrical work, it is essential to disconnect the power supply to the circuit. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Work in a well-lit area and avoid distractions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Remember, electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. In conclusion, while using a SO cord directly through a wall for a 12 volts DC awning motor might seem like a straightforward solution, it violates the NEC prohibition on running flexible cords through walls. Several alternative methods, such as using an exterior outlet, a junction box with conduit, or Type NM cable, can provide a safe and code-compliant installation. By carefully considering the specific requirements of the application, selecting the appropriate materials and methods, and following all applicable codes and regulations, you can ensure that the awning is wired safely and reliably. It is always advisable to consult with a qualified electrician or electrical inspector if you have any questions or concerns about the wiring installation.